Hello everyone, welcome to Start Tech. In today's video, we are going to discuss structured streaming in Spark and its advantages over de-streaming. If you have not watched the previous video about de-stream and how it works, please I would suggest you watch that video before proceeding to this video, because if in an interview you are asked about de-stream, you would be in a better state to answer those questions. Okay, so having said that, we'll start with today's video about structured streaming. So why structured streaming? We already had de-streams in the indie stream. What would happen, like under the hood RDDs will be working on it, having a micro batch kind of application, having a micro batch for a streaming data for, and under the hood RDD would be working on that. Then why there is a need of structured streaming? So structured streaming, there are these streams, there are some disadvantages. So what are those disadvantages of D streams? So D streams works with batch time. Like in a particular window, if we get some Twitter data for every minute or every second or every window interval we provide, and in that only the data would be analyzed and processed. That would happen, but it won't happen for a event time. So that advantage structured streaming gives you over the de-streaming. You cannot take advantage of, if you had a batch job and you want to convert it into streaming job, so that is difficult to obtain using de-stream, but which is very easier to do it in a structured streaming, as under the hood we have data frame and data set working on that, and we'll see. And the APIs which structured streaming offers are much more powerful, and you no need to take care of exactly one semantic which we discussed in previous video, like fault tolerance. It need not need to handle checkpointing and all those stuff which we discussed in the previous video. So the headache of the developer is removed due to that, and developer will only concentrate on the business logic rather than all the fault tolerance concepts. So this gives the advantage of structured streaming over de-streaming. Okay, so what is exactly structured streaming means? Like, it is considered as a unbounded or infinite table, and every stream would be appended into that table. Suppose you are having a Twitter data, and you are getting all the tweets in a tweet table. Then the tweets which come the latest or the current minute, those would be appended into the table. So structured streaming, it is considered streaming data as a table. New data in the stream would be appended in the infinite table. So that is what the concept is. So now consider that you have a batch job like this. So we have some data, okay, which has origin, destination and call charge. So this kind of a telecom kind of a data, and you are processing like a JSON file, you are reading it. This is a batch job, you are doing some where clause in this, and you write it into the output location in a Parquet format. So this is what your batch job is. Now if you want to convert this batch job into a streaming job, you pause the video for a minute and think about it using de-stream. So how much headache you would have to convert this job to a de-streaming job. So now in streaming, like using structured streaming, the thing is only using the API, advanced API like read stream, and you just mention what is your source, like is it a Kafka, Flume, all the others those advanced APIs it supports for structured streaming. So this headache is removed, and we have now beautiful APIs, so that can help us in converting a batch job into a streaming job. So that is the biggest advantage of structured streaming in Spark. So now we'll discuss some of the output modes which it offers. So append mode, it offers three kind of mode: append mode, update mode, and complete mode. In append mode, only new rows are appended to the table. So this mode is by default, and as it says, like, since the last trigger, it will write, you know to the external storage, whatever you define. So you need to define that in a when you write the code for that, like when you write the output format for that. Okay, at that time you need to mention like what would be the mode. And update mode, like, only if you have existing data and there are some rows which are getting updated, and if you want to change only that, then only update mode is useful for doing that. So this update mode is specifically used for a MySQL or SQL kind of data you are pulling in. And if the data gets updated, if suppose we have an employee data and employee resigns or leaves the organization, and then it gets updated, so in that kind of scenario, few rows were updated, and since the last trigger, it will change the external source where you are writing the data in the sink. It may be any HDFS, S3, or any database, right? In complete mode, entire, like, update, latest updated, as well as update like any updated transactions. So it will consider all the three, all the both the two in a complete mode. Under the hood, how it operates now, like, under the hood, in the Spark streaming application, it differs from the batch application. How it differs: it creates incremental execution plan, like you can see in this diagram. Planner will use the knowledge of converting streaming logical plan to number of incremental execution plan. So that is what makes it different from the batch processing application. So this is how under the hood the planner would work on. So that's about it regarding Spark streaming. I hope you like the video, and also do watch other videos on our channel. Do comment like what all videos you would like to see. In the next video we will continue this series, and do let me know in the comments what would you like to watch on this channel. Thank you for your time, and bye bye.